So hello everyone, myself Subroto Payan. I have completed my BTech and MTech degree in electrical engineering. I worked in a software company for around 3 years. Then I joined my research. My broad area of research is brain-computer interface. For computational purposes, I use the graph learning framework utilizing graph signal processing and graph neural network based methods. So today's topic is uh, gradient descent and the Autograd, very basic and very useful functionality, and the computational graph that the fighters use for building the Autograd functionality. So suppose that we have a very basic neural network with some inputs. I hope we all are familiar with this. There is a activation function and there are some loss computation and the output that is y predicted. Now clearly here the loss can be computed as b and y true if we subtract this y predicted with y true, and suppose we are using a mean squared error loss function, then the loss can be computed as b, and for the weight of this we need to compute this the partial derivative with respect to the parameters, weight parameters that are defined in here. And also we have the parameter b, the bias term. So we can use the chain rule to compute this. So the forward path we get y predicted, and the backward path, the weight update we can get from the chain rule. Now how to use this with a build a computational graph out of this, and how Autograd performs. So very simply, so we have the inputs here x, so which gets multiplied with the weight, okay, and it is added with the bias term. It passed through the tan h, a nonlinearity or activation function, and then the loss function is here, maybe a squared loss, and the y predicted. This is the forward, this is the loss, and this was the forward path. So this is the direction of the forward path. So these are the parameters. Now this thing is called a computational graph, and these things are called the nodes of the computational graph, which computes all the calculations. Suppose in this particular node it is calculated, so wx is coming here and it is adding with the bias term. So this particular node has all this information, how the equations are coming, and the actual computation it is performing, and the store values also in here. Now if we see the example given in our course material, you can see, yeah, this is the example. So this particular example I have used for this. So this is the your MAC loss, mean squared loss function is computed here, and this is the forward path exactly as I mentioned. Now we can use any other loss function here, that is not an issue. Now if we can see the simple function, okay. So there are the tensors W and V, and here the reverse grad 2 is used, that is the gradient is computed for this tensor. Now the prediction term. So prediction term is easily can be computed. That is, we have that the weight that is multiplied with the input and the bias term, and this is first non-linear activation function, that is tan h, and we will be using the inbuilt tan h function. So it is our prediction term. And what would be our loss term? It is very simple to define. So the loss term is defined as the mean squared error loss, that is y true minus y predicted upon the whole square. So that's it. Thank you.